everyone! Today I will introduce you to a 2.1-inch knob screen development board. The core of this knob screen is still ESP32-S3. However, this knob screen is a relatively complete hardware device with shells. This is a fully encapsulated development board. The front is a round screen. Then the core board of ESP32-S3 has been encapsulated inside the entire shell. Then connected to the outside through a flexible cable. We used a small adapter board. Convert this cable to USB. Then power the knob screen. Essentially, this knob screen is still an ESP32-S3 development board, but you may not see its internal structure. There may be some confusion, so I will take a similar ESP32-S3 development board to compare and explain it to you. Both of these are ESP32-S3 development boards. You can take a look. The metal shell here encapsulates the ESP32-S3 module. This round knob screen also has an ESP32-S3 module inside, which is the same as this one. It is our 1.6 and 8 model module. Our 16 represents its flash. The flash memory of this knob screen is 16M. Our 8 means its PSRAM is 8M. That is to say, the flash of the entire knob screen is 16M. PSRAM is 8M. Under such a configuration, we can make many LVGL or other interfaces on this knob screen, because its flash and PSRAM are large enough. In addition, you can take a look at this development board. The ESP32-S3 module comes with a black printed circuit board antenna. This antenna enables the entire knob screen to also have the function of connecting to Wi-Fi and Bluetooth. We can connect to this knob screen wirelessly. The connections here can be programmed and designed by yourself. The knob screen can be used as a server, or your phone or computer as the server. Log in using the analysis screen. Bidirectional server and client designs are both possible. Point-to-point communication and point-to-multipoint communication are also possible. Of course, the knob screen itself, ESP32-S3, is just an MCU. Therefore, the computing power and operation of its MCU module are limited. It is recommended that you make it a simple server, or use it as a client to log into other resource-rich devices. That is to say, in the actual programming process, you should pay attention to the resource configuration of the entire development board. After all, it is a development board with limited resources. This development board comes with a knob. Our ordinary square development board does not have a knob. You can think of the knob as being essentially a rotary encoder. Here I will show you the rotary encoder through pictures. You can see that I have 3 pictures displayed on the screen. One is the common rotary encoder. Of course, the physical properties of the rotary encoder of this knob screen are quite special. Its shape is not the common rotary encoder with a knob. It is a special kind of rotary encoder. The rotary encoder is then controlled and the data is collected by the ESP32 module. Then communicate with the circular screen. In other words, this knob screen is a small device, a complete hardware system, input via rotary encoder. The processor MCU performs a processing. Can be displayed on the screen, that is to say, this system has an input. There is a central processing unit. Then there is an output display. We can compare this square development board. You can take a look at this square development board. There is no rotary encoder. It also has a screen. If we use the rotary encoder, can be connected through the GPIO interface on both sides of this development board. We can connect a rotary encoder to this development board. This square development board, after connecting the rotary encoder, in essence, the hardware configuration is very similar to that of the knob screen. It's essentially the same system. Let's take a look at the screen of this knob screen. It is different from the common screen we see. It is a round screen. The processing of this round screen is different from that of the square screen. We can think of this circular screen as an inscribed circle of a square of the same size. Now we use this rotary encoder. The content is then displayed on the screen through the MCU. This screen is a 2.1-inch knob screen. Its resolution is 480x480. At this time, we can use a 480*480 square screen to calculate the corresponding coordinates of the circular plane. In other words, we can regard this circular screen as a square 480x480 screen. Then we only need to calculate the coordinates of the circles on the square screen. In addition, we need to note that this rotary encoder is not just a knob. This rotary encoder can rotate clockwise and counterclockwise. We've already connected it to the brightness value using the program. Rotating left and right will adjust the screen brightness. Let's make a bigger adjustment so you can see it. Now the brightness is very low. You can see it is 2 or 3. It's darker when you see it. Let's brighten it. This is the function of a rotary encoder. This knob also has the function of a button. That is the function of a button. You can take a look. On the back side, it is the axis of rotation. This is rotatable. It is also pressable. When you press upward, you can see a physical change. There is an action of pressing down. We also designed a downward pressing action to react on the screen. After pressing down, the screen is turned off for 2 seconds. Then restart. We use the function of the rotary encoder. Then use the rotary encoder to control the screen backlight brightness. You can see that the brightness of the backlight is displayed on the screen. There are 2 sets of numbers. One is displayed in a text box. Another is to use a plain text display. You can see that when we adjust. It will display synchronously. This rotary encoder has a very sensitive response speed when adjusted. We just need to adjust it slightly. It will produce a change in brightness. In addition, we also use a circular scroll bar to synchronously display the brightness. You can see that as the brightness increases, the scroll bar gradually becomes longer. Such a rotary encoder is one that can rotate infinitely. It can keep rotating. Of course, this value has a range. It is from 0 to 255. When the value increases to 255, it will automatically restart from O. So you keep spinning. It will keep going into this cycle. Of course, it can also rotate in the opposite direction. Similarly, jump from 0 to 255. You can design some programs for rotary encoders through third-party libraries. Because the rotary encoder can rotate clockwise and counterclockwise, many programs can be designed, including its buttons. This button is also the boot button of this development board. Long press it and then cut off the power to make the development board enter the boot state. That is, the downloadable state. We can upload code to this development board through the boot state. We can also use this button, for example, long press and short press. Mouse-like operation. Double-click and single-click to design some operations of the program. For example, we can design some LVGL buttons on the screen. Then select by rotating the encoder. Then there is no problem in confirming and exiting through this button function. You can design some operations related to the knob according to the user's daily operating habits. Also note that the knob screen has Wi-Fi and Bluetooth functions. We can control this knob through a mobile phone, computer, or other hardware. You can also control other home appliances through the knob. For example, we can connect to home appliances through physical connections. This is a UART communication protocol cable. We can directly connect this cable to the control panel of a washing machine or an air conditioner or refrigerator. Then use the knob to design the program to control the relevant home appliances. Achieve the goal of a smart home appliance. Some home appliances do not have the ability to connect to the internet. We can use knobs to control home appliances not only through knobs. You can also use the knob as an intermediary to achieve network connection. You can also use multiple knobs or other development boards. For example, the knob and this ordinary square board can also be interconnected because they all come with an ESP32-S3 module. We can interconnect multiple development boards through the ESP32-S3 module. Okay, let's summarize. The core of this knob is a rotary encoder. Then this rotary encoder has the function of a button. It is an ESP32-S3 module. Development board as a central control unit. We can use the Wi-Fi and Bluetooth functions of the ESP32-S3 module to enable this knob, and other devices to achieve wireless interconnection and intelligent connection. In addition, the screen of this knob is a 2.1-inch round screen. The resolution of this circular screen is 480x480 high resolution. The display is very clear. This knob screen is physically connected to other devices through a cable. The entire cable is the UART communication protocol. We can connect to other devices physically or wirelessly. Okay, that's it for today's video. Thank you for watching.